So now let's put all the pieces together, okay? So if we're going to graph a polynomial, and we've kind of already been building into this as we've gone through, the first thing that we want to do is we want to use that leading coefficient test. We want to figure out which ends up, which ends down, both up, both down, what's going on with that. Next thing, we want to get our x-intercepts or our zeros along with their multiplicity. Go ahead and put that idea in. Then y-intercept. Y-intercept is just going to be, we're going to plug in 0 for x, and then that's just going to give us another spot on the graph that we know we have to utilize. Now, symmetry is down further in my list. Symmetry goes back to when we talked about whether or not a function is an even function or an odd function. And so, but we can utilize some of our x-intercepts and our leading coefficient tests, something like that, to decide whether or not we have symmetry from the get-go without actually having to decide even or odd. And then we'll use our turning points. And remember that we're going to try and use as few as possible, knowing that we can always bump those up, but we don't want to have to bring them down. So here's the example that we're going to use. They talk about the 5-step strategy. That's just the ones that we just talked about. So they want us to find f of x equals 2, and then x plus 2 in parentheses squared, and then x minus 3 in a set of parentheses. So we're going to talk about how to pull all this together. So we're going to pull this over here. So I've got some on board. Now, first thing is thinking about end behavior. If I were to, again, kind of expand this out, okay, if we were to multiply these two together, I would get an x squared with a bunch of stuff after it. If I were to then take this x plus 2 piece and combine it over, I would get an x cubed with a bunch of stuff behind it, and then pulling in that 2, I would have a 2x cubed with a bunch of stuff behind it. No, I'm not worried about the stuff back behind it because I just need that front piece. So now, again, I'm going to use my dark purple here to indicate the stuff that we know, and then we'll move from there. So I have x cubed, so that is an odd power. So that means we're going to act like a line. And then I have a positive 2, so that means we're going up a hill. So I'm going to get started by putting this end up, this end down. Now I may have to squeeze those in or move out a little bit, depending upon the rest of our graph stuff, but that at least gets us a start. Now, next thing is my zeros, okay? So again, because they've given it to us in our factor form, we're going to take x plus 2, and we're going to set it equal to 0. I'll subtract 2 from both sides. So my 0 is at -2 twice, okay? So it has a multiplicity of 2, which means that is a touch and turn. And then we're going to do our other one. So we've got x minus 3 equals 0. I'm going to add my 3. So I've got x equals 3. Move this up. This one was only there the one time. Okay, so it's just there that single time. So this one has a multiplicity of 1. So that means this is a cross point. So we'll go add this to our picture. So over here at -2, I've got a point, and then also at 3, I have a point. Now, at the one at -2, we said that that was a touch and turn. So if I'm going to come up from this one, there's that touch and turn right there. Over here for the one at 3, we said that was a cross. It is a singleton. So we're just going to do a straight up version because it's going to have to connect. I am going to move that little arrow over just a bit, okay, so that it looks a little more in line. So that was my zeros. So if we're talking about steps, this would have been kind of the first thing. This would have been our second thing. Third was our y-intercept. Now, that means we're going to plug in 0. So we're going to do 2 times 0 plus 2 squared times 0 minus 3. So I've got 2 times 2 squared times -3. 2 squared is 4. So I've got 2 times 4 times -3. 2 times 4 is 8 times -3 is -24. So I'm going to extend this down here. I'm just going to put a dot down here and say that's -24. I'm not going to draw all those little points. Now, 4 was, okay? Now, I can use my graph stuff to help me sort this out. First off, since both ends are going in opposite directions, it is not even. Remember that even symmetry has to do that fold in half thing on the y-axis. That can't happen if this end is up and that end is down. So it's not even. Okay, now it could be odd because remember, odd is where we put the little push pin right there on the origin and we turn it around 180 degrees. That'd be cool. Here's the issue though. If I have this one that crosses this way, then if that rotated, then I should have one over here at -3 that crosses downwards. That doesn't happen though, because I don't have a spot over here at -3. I've got one at -2, but also if that happens and this was a touch turn, then I should have another touch turn going this way at 2. So it's not odd. So I actually don't have any symmetry at all. Now, 5 was our turning points, okay? Okay, so its biggest power, which we already figured out was cubed over here. So it's 3 minus 1, which is 2. So I'm only allowed 2, and y'all, one of them's already here. So now, what could this graph possibly look like? Okay, utilizing the stuff that I know, still only using 2. So maybe it looks like this, where that other turn is down here going through that y-intercept. Okay, that may be one of it. The other option, or another option, could be that turn, okay, happens before. There's another one where it could happen after. I don't know. And again, we don't have to have 100% complete knowledge of what this graph looks like. But we do know certain parts of it. Again, kind of these dark purple spots and behaviors there are what we know. This kind of blue and reddish color are possibilities. And it may be something that's somewhere in between each of those.